Hi there, this is UMUA 2017, paper 1, question 15. So we have this function, minus 2x squared plus 10, and we're given three transformations of f of x, and we use the trapezium rule to estimate the area under these curves between 0 and 1, and we want to know if we get an underestimate or an overestimate for each area. Okay, so the first thing to notice is if we have a curve that is curving upwards like this, or what we call convex, then when we use the trapezium rule, the top of the trapezium lies above the curve, so we're going to get an overestimate. But if we have a concave curve, or one that's like curving this way, then when we use the trapezium rule, the top of the trapezium lies below the curve, so we get an underestimate. Okay, so to work out whether we have overestimates or underestimates, let's look at whether our curves are concave or convex. So this is the function that we were given, and the first curve that we're interested in is just y equal to f of x. And f of x is just a quadratic, but because there's a minus in front of the x squared term, it's going to be more like a sad face rather than a smiley face, if you know what I mean. So f of x just looks like this. And if you work out the roots of this quadratic by putting f of x to 0, then you'll see that you get plus and minus root 5. Okay, and the next curve that we're interested in is y equal to f of x plus 1, and this is just a translation of this graph by minus 1 in the x direction, right? So graph number 2 looks like this, and the roots are just going to be plus and minus root 5 minus 1. And for our third graph, that's the same as this, but now with a reflection in the line y equals 6, so graph number 3 looks like this. Okay, and we're looking for the area between 0 and 1, right? And because we know, of course, that 5 is greater than 4, then that also means that the square root of 5 is greater than the square root of 4. So on this first graph, 1 is going to be in here somewhere. So we're going to be looking for this area here, and because we can see that our curve here is concave, we're going to get an underestimate. And similarly for this one, because root 5 is greater than 2, root 5 minus 1 is greater than 1, so again 1 is over here somewhere, so we're looking for this area, and again our curve is concave, so we have another underestimate. And now for the last curve, this bit here is concave, but this bit is convex. So we're going to want to know where it turns. So this is the curve f of x plus 1, so just putting x plus 1 into our f of x. And where it turns is when y is equal to 6, where it's reflected. So putting y is 6, we can rearrange and then divide by 2, square root minus 1 from both sides to find out the x value of these turning points. So this one here is minus 1 plus root 2, and root 2 is like 1.4 something, right? So this is approximately 0.4. So our 1 is going to be over here somewhere. Okay, and if we had just, if we just had one trapezium, then obviously we'd be overestimating. All of this would be overestimate. But even if we didn't, we still have more bits where we're overestimating than where we're underestimating. So overall, we've got an overestimate. So the answers we're looking for are underestimate, underestimate, and overestimate for 1, 2, and 3 respectively, and that gives us answer B.